Hi everyone, in this video I'll be showing you how I completed my task 3.1b using Arduino Nano 33 IoT and the BH1750 light sensor. We will connect the device to Wi-Fi, measure sunlight and trigger IFTTT events when sunlight starts and sunlight stops. The requirements for this were hardware, Arduino Nano 33 IoT, BH1750 sensor, and a smartphone or computer with a USB cable for the data transmission. Software was Arduino Web IDE, which I am currently open, and IFTTT account for cloud integration. For the understanding of the code, first included all the libraries. For I2C communication, I use wire and then BH1750 for light sensor and then Wi-Fi NIA for Wi-Fi and Arduino HTTP client for sending requests. Then we store a Wi-Fi SSD password. This is how the Arduino connect to the internet. Then we store. Then we also set the IFTTT host as maker.ifttt.com on port 443, which means secure HTTP connections. Finally, we provide the IFTTT key, which is a secret token that links Arduino to or on IFTTT applet. Then next we define two IFTTT events, sunlight started and sunlight stopped. And then there will be sent these will be sent to IFTTT when sunlight is declared, detected or lost. After that we set light thresholds above 200 lux. So above 200 lux means sunlight has started and below 550 means it has stopped. Basic. We then create objects for BH1750 sensor, these ones, the secure Wi-Fi client and the HTTP client. Finally, we declare variables to track whether the system is in sunlight, whether the state changed, total sunlight today, and when the day begins. Here. After that, this is the Wi-Fi and sensor function part, in which the connection Wi-Fi shows that function shows connection in which the Wi-Fi function connections the board to Wi-Fi. It keeps retrying until a connection is successful. Once connected, it prints the device IP address, and then the read.lux one function is very simple. It just return the light level index using the light sensor here, and then IFTTT function. The send IFTTT event function is responsible for sending data to IFTTT. It builds the URL path using the event name and our IFTTT key. Then it creates a JSON body with up to three values that can be passed to IFTTT. Next, it makes a post request to the JSON body. Finally, it checks the status code from the IFTTT and prints the response. After that, the state machine one, the check sunlight one. Here, this one. The whole para is the whole code snippet is about state machine. The check sunlight function is the brain of this project. It reads the current lux value and prints it. If the system was not in the sunlight and now the lux is above 200, it marks sunlight as started, records the time and sends the start event to IFTTT, and then we get the notification of the sunlight started. If the system was in sunlight and the lux falls below 150, it means sunlight has stopped. Calculates how long the burst lasted, adds it to today's total and sends the stop event, the stop notification we received. If the every 24 hours it resets the daily sunlight counter. Every 24 hours, our code will reset it, and then we got setup plus loop. The last part in this in setup, we start the serial monitor begins I2C communication and initializes the BH1750 sensor. We send connect to Wi-Fi and record the starting time of the day. In the loop, here in the loop, the Arduino checks sunlight every 1 second by calling check sunlight circuits. This way, the system constantly monitors the environment and triggers IFTTT whenever sunlight changes. In the last, that's it. We use Arduino Nano 33 IoT and BH1750 light sensor, integrated it with IFTTT and successfully triggered events when sunlight starts and stops. Thank you so much for watching.